I would like to do several other examples of finding trig function values for non-acute angles. The first example, given that sine of theta is equal to negative 1/2 and theta is between pi and 3 pi over 2, find the cotangent of theta. The first thing here, once again, knowing that sine is equal to negative 1/2 means that I need to determine which quadrants that is possible in. So sine of theta equaling negative 1/2 could be gotten only from the negative being in the top with the 1 and the positive being on the bottom with the 2, seeing that the ratio needs to be y over r. R can't be positive, r can't possibly be negative, so it has to be a positive 2. That means that the negative needed to go with the 1, and that means that that would be the y value. Now, which quadrants would this possibly occur in? The only quadrants that y is negative in are quadrants 3 and 4. So this is possible in quadrant 3 and quadrant 4. Now, in this particular case, they were actually nice enough to tell us which quadrant we are located in. This particular problem says that theta has got to be in between pi and 3 pi over 2. That actually means that we are in quadrant 3. And so that would be the quadrant that you want to look in. You don't need to worry about the quadrant 4 case. So I need to find cotangent of theta. Draw a picture. We are in quadrant 3. We need a triangle that has a y value of negative 1, an r value of 2. Now in this particular example, I don't really need to do any work because I know an angle that has a hypotenuse of 2 and another side of negative 1. Okay, the other side would be labeled as the negative square root of 3, and what that would do for me is it would give me a reference angle of 30 degrees next to the negative square root of 3. So this one I don't need to really do any work to find that missing value of x because that missing value of x is known. Now, that being the case, I want to find the value of cotangent of theta. Cotangent of theta is the ratio x over y. The x value is negative square root of 3. The y value is negative 1. That would reduce to positive square root of 3. Okay, let's look at another example. Find the exact value of secant 13 pi over 4 by using a reference angle. Now earlier we talked about, I believe, a value of negative 7 pi over 4 when we were in the reference angle lesson. In this particular situation, I'm going to talk about 13 pi over 4 by thinking about where is 12 pi over 4 located. 12 pi over 4 is close to 13 pi over 4. 12 pi over 4 would reduce to 3 pi. That would mean we rotate around 3 times. Okay? 3 pi times. And so let's think about drawing this. Okay, 13 pi over 4, we know we need to go counterclockwise. 1 pi would be right here. 2 pi would be right there. 3 pi would be right here. Okay, 3 pi is the same thing as 12 pi over 4. Now, how far away are we from 3 pi over 4? I'm sorry, how far away are we from 3 pi? Well, we're a pi over 4. We need to rotate one additional pi over 4 to get to 13 pi over 4. So an additional rotation of pi over 4 would put me right here. That would end up being my terminal side. So there is 13 pi over 4. Okay, now on here, I need to draw a triangle. So draw your right angle up to the closest x-axis. We need to know the reference angle. Because we counted by pi over 4s, the reference angle is pi over 4. Okay, we need to label this triangle using the appropriate x's, y's, and r's. Because this is a 45-degree reference angle, we know that the hypotenuse is the square root of 2, and the other two sides are 1s. But because we're located in quadrant 3, we need to make sure we have the right signs on those 1s. The x value would be -1, and the y value in this case would be -1. So secant of 13 pi over 4, the ratio is r over x. The r value is the square root of 2. The x value is -1. So this would be negative square root of 2. This concludes my other examples over finding exact values for trig functions of non-acute angles.